All right. Well, thank you everybody for joining today. I know this isn't optimal being a virtual presentation, but I'm super excited to be in your virtual presence to talk about something I'm pretty excited about. And there's been a lot of buzz about this in the industry as of late. And there are vendors that have popped up all over the place, and there have been vendors that have been around for quite some time in this space. And this is really about observability. And you know, the intent of this talk is really not to be an Azure focused talk. Really, the idea here is that Azure is really just an implementation detail for these concepts. Any cloud vendor will have tools and technologies and libraries that you can use to do very similar things that I'm going to cover in this talk. So again, it's really more about the concepts, and I am using Azure as an implementation detail here, simply because that's what we use at my employer. So with that being said, what I'd like to do is hand out some thank yous before we really get into the details here. I'd like to thank Code on the Beach for allowing me to participate in the conference. I wasn't sure I was going to be able to, but Paul Irwin opened a door for me to give this presentation today. So I wanted to extend my thanks to both Code on the Beach and to Paul Irwin for the opportunity to present. I also want to thank my employer, Sudeth. Without their support, I wouldn't be doing this at 2 o'clock in the afternoon on a Tuesday. And then, of course, everybody who came to this talk, I want to thank you for being here. Like I said, I know this isn't optimal being a virtual talk, but I'm glad that you came, and I'm really excited about this material, and I hope you are as well. So we'll bounce into some introductions. Okay, that's my big face on the screen. Let me get that a little bit better there. Yeah, my name is Michael Mann. I'm a technical lead for a moving and logistics company in town called Sudeth. And Sudeth has been in business for over 100 years, and they'll probably be in business for 100 more years. But moving and logistics is a very interesting space. There are a lot of problems to be solved there. Some of the things that we're talking about today are some things that I've been pushing for in our applications. Because we have quite a few applications at Sudeth. Interestingly enough, Sudeth has applications in just about every space that you can think of. And we have quite a few of them. So, observability becomes extremely, extremely critical when you're supporting people out in the field that are executing moves on a daily basis. Even for our sales team that have to go out and estimate moves on a regular basis. So, stability in applications is very critical. And with having so many applications, it's critical to start layering in observability into those systems. And, I'll talk about a little bit more about what observability is as we get into the talk. But that's a little bit about me. And then again, here are some things that we'll talk about. We're going to talk about the terms health monitoring and observability. These are three distinct terms in my mind, but they all cohabitate in a similar space. We will talk about them distinctly, and we will also talk about the tools and technologies available within the .NET ecosystem and the Azure ecosystem to support these concepts so that you can layer these concepts into your applications today. We'll also take a look at health monitoring and observability in the context of an existing system. So it always helps to look at an existing system and see how you can layer these concepts in. Interestingly enough, the system that I'm going to talk about today, we'll get into more of the details of that system in a little bit, but that system was built, I believe it was in 2017. It was not built with observability in mind, but What I want to demonstrate today is that's okay. It doesn't have to be. You can layer this in incrementally into your applications and then get the benefits from that. So it's something that you can bring into an existing system and then incrementally layer in over time. See, one more thing here. I do want to talk a little bit about our organizational structure. So forgive me for backing up a little bit here. I think organizational structure is really critical to understanding, how teams build and deploy software. So, just to give a sense of the organizational structure at Suddeth, we're divided into 3 divisions. We have the moving and logistics division. We have the Sterling Lexicon division, which focuses on international moves primarily. And we also have a government services division. As I mentioned earlier, I'm the technical lead for the moving and logistics division. And the way that software gets deployed to our end customers is through these different layers. So once a year, we have a budgeting session that happens around October. And then we have product owners over each of the different products that we have within our organization. And just to give you a sense of the number of products that we have in the moving and logistics side, that really, they break down into about, I believe it's 8 key areas. So we have quite a few product owners in the moving and logistics division. And then they all build their own roadmaps for their products. And that happens as a part of our budgeting process. And again, that happens in October of every year. And then provided those dollars are approved by the business, then what happens is the product owner works with the technical lead, which would be myself, to execute on their vision, right? They have the dollars, they've been approved, and now they're ready to spend those dollars to execute on their vision, right? And so that my responsibility as the technical lead is to help them see their vision come to life. Now with Suddeth, it's an interesting model. We have both internal staff and we also work with contracting partners like Feature 23 to execute on these different applications and the visions that our product owners have. And so my responsibility is to work with both internal people and external partners to build software, and then throw myself in the mix as I possibly can, right? And then we have a DevOps team as well, and then we also partner with our DevOps team to get the applications deployed to production. We use Azure DevOps to deploy our apps. So within Azure, you have this concept of a build pipeline and a release pipeline. And then, of course, Azure also has this concept of infrastructure as code, where you have ARM templates or Bicep. And if you're not familiar with ARM templates or Bicep, that's fine. It's just a way to express your infrastructure as code so that you can deploy your applications. So, there are many layers involved in getting code deployed to production. And then there are different parties involved in ensuring those applications are delivered in a consistent way and in a secure way. We also have a security and compliance team at Suddeth. So anytime we develop either a new product or an extension to an existing product, we have to work with our security and compliance team to make sure that our security patterns and practices are in place. And then we also have an architectural review board that we have to put our applications in front of so that they can review the architecture of the system and then provide recommendations on adjustments to that architecture if they see anything that is out of alignment with our standards. The Suddeth technology landscape, let's just go through this a little bit here. Obviously, we're a Microsoft Azure customer. Any applications that we build, we're building for cloud first implementations, if at all possible. We use Azure DevOps for source control and continuous integration and delivery. Our applications are broken up into an Angular spas typically with an API backend. All of this is written in C#. We have desktop applications implemented in WinUI 3, which is a relatively new technology out of Microsoft. We use Realm, which is a database technology for client-side databases for desktop applications. And then, of course, the desktop applications make API calls. Again, those are implemented in C#. And then we have mobile applications, both for Android and iOS, and then that is implemented in Xamarin Forms. And again, we use the Realm database for the local synchronization of that data from the client to the server through APIs. So that's an idea of what the technology landscape is at Sudeth. Now, the interesting thing to me about all of this is that, Sudeth really has they have the full gambit, right? They have web applications, they have desktop applications, and they have mobile applications. And then you can layer in observability into all of these. So there is no place that you cannot put observability into a system. So just keep that in mind. And we are rolling in these capabilities into each of these applications today. All right, we talked about what we're going to cover in this talk already. All right, so now we'll just go through some terms here. Now, the interesting thing is I really couldn't find anything on system health, which I thought kind of strange, and maybe it does exist. But what I decided to do is to look at what was defined as system health when you're looking at the physical body, right? Because I look at the physical body as a collection of systems that need to interact with one another. Software is different, but it's very similar as well, right? The complexity of the systems that we build, typically there are a host of web services that are involved. There may be backend systems that are involved that are maybe batch in nature, right? And so you have all of these interoperating parts that need to cooperatively work together, right? And the idea here is that the way that I look at the health of a system, just like the health of the human body in this example, is that all of those parts are working cooperatively together to achieve a means to an end, right? And so you want to make sure that if component A needs to talk to component B, that component A can talk to component B, right? And then component B is not down, for example. So that is how I look at system health. And then monitoring, coming right out of the Google SRE book, is really about capturing metrics about your system using logging techniques. And so what you really do, you do want to, and we used to do this way back in the day, right? 15 years ago, you used to have IIS, and then you would look at the performance metrics of IIS and take a look at things like, what is my request queue length? What is my disk queue length? What is my CPU utilization? Things like that. And you can look at different metrics of a system to understand if that system is operating within tolerance levels. But monitoring really focuses on, again, the metrics around a system to make sure that they're within the acceptable tolerance levels that you expect. And then observability is really about asking questions of your system and getting answers. This is very similar to me than machine learning models. If you've ever worked with a machine learning model, you can query the model, right? You can give it example inputs and it'll give you a predictive output. And so observability is really a similar concept where you want to be able to query your system and understand the attributes of the system or the state of the system. Honeycomb is a pioneer in this space and helping to define what observability means. But really, their concept here is not necessarily knowing the question you want to ask, but have tools available at your disposal to slice and dice information and get at information to know about how your system is performing. All right, so let's take a look at a running system. This is a system that we use at Sudeth today. The name of the system is called Estimator, and Estimator is primarily used by our salespeople. And what our salespeople do is they will go to a site and with a tablet, typically, and they will pull up the Estimator application, and the Estimator application gives them the ability to perform an estimate on site on how much it will cost to execute that move. Now, Estimator is used in our business moves space, so you can think of customers like Amazon or Microsoft, who are two of our customers in the business move space. And so, you know, Estimator, again, is it's a bit of a complex application, right? Because it has to handle things like synchronization from the tablet to the server. And not only that, but within Estimator, you can do things like share proposals with other employees in the organization. And they can make changes to that estimate as well. But we're going to look at this application and look at how we could incrementally introduce observability into this application. Not just observability, but also you know, health and monitoring. So what are some of the high-level components of the system? Well, it's a desktop application, which also runs on a tablet. It has a web application for managing rates. So if there are rates that are specific to a customer, those rates can be uploaded through this web application. We also have a separate application for managing custom inventory. We have, you know, the web properties are hosted in Microsoft Azure. Our authentication authorization partner is Auth0, so we do not roll our own authentication and authorization. We use Azure Blob Storage to store documents. So, you know, when a proposal is saved, we'll save it out to Azure Blob Storage. And then we use a hosted SQL Azure database for, you know, the storage of the data related to the proposal. All right, here is a high-level architecture diagram for the desktop application for Estimator. You can see that we've got a WinUI 3 app on the left-hand side. It has that Realm database that we talked about. So data is stored locally and synchronized to the server. You can see that we've got an Auth0 integration here where we handle the authentication authorization. We have a mobile API to handle any synchronization between the desktop or tablet and the server, and also from the server down back to the tablet or desktop application. We also have a separate proposal generation API. So the generation of a proposal, it generates a PDF document of that proposal. So we have that separated out into its own API. We have a workflow piece to this as well. So a proposal can be transformed into what we call a move order. And a move order is when, you know, within our transportation management system, which is down at the base of this drawing or diagram, that is where we handle the execution of the move, is inside the transportation management system. So the desktop application has the ability to take a proposal and turn it into an order in our transportation management system. And it uses this order creation workflow piece, which is a logic app, if you're familiar with Azure parlance there. And then, of course, you've got Azure Blob Storage in the database, the relational SQL store there. And then, of course, we're using something called hybrid connections to connect from an Azure resource to an on-prem resource. So our transportation management system looks like it was built back in the 90s, and it runs on our own infrastructure at Sudeth. And so we have to connect the resources in Azure to that transportation management system that runs on-prem, and that's what the hybrid connection is used for. So you can see we've got a lot of moving parts here. We've got our rate management web application. This is much simpler, right? You've got a very simple web application, again, Auth0, and then you've got this ASP.NET Razor application. I know I talked about that we had Angular spas as our primary web application framework, but this was built a while back. And so it was implemented in ASP.NET Razor Pages, which is fine. So this is a much simpler application. And then we have our inventory management web application that looks like it has as many moving parts as the desktop application, if you look at it. So, the additional pieces here is that we're using Azure Functions for some synchronization capabilities. So we do synchronize users from Auth0 into our local database. And we also synchronize some user data from our transportation management system into our local database. And so we have a lot of moving parts here as well. And of course, all three of these applications share the same database, just so that is understood. All right, so now that we know about the three applications that we have that support Estimator, let's talk about health checks. So if you're not familiar, health checks have been available in ASP.NET Core for some time. And really what a health check is it's an endpoint that your, we'll call it your API exposes that tells you whether or not that resource is healthy or not. And so with that, you can do a number of things. If you can implement your own probes to go poke at that health check endpoint and then ask the resource, are you healthy? And then the resource will tell you if it's healthy or not. You could also set up some infrastructure within Azure to do the same thing. So it will automatically check to see whether or not your application is healthy or not. So health checks are a library. You can pull it down from NuGet. You can implement it into your applications. And again, we're talking about the system health again. And I wanted to bring this back up because the way that I have viewed system health, or at least at Sudeth, is really the connection between systems. An example of that is, like for Estimator, if for some reason I can't write to Azure Blob Storage, that's a problem, right? And then that would mean that that part of the application is not healthy, right? Therefore, the system as a whole is not healthy. Or if for some reason it can't make a call to the synchronization API, right? Now, if the synchronization API remains unhealthy for a fair amount of time, that could be a symptom of a problem. If it's unhealthy for a short period of time, it may not be an issue. But if it's unhealthy for an extended period of time, that would be something we would want to know about. If we can't write records to the database, or another example is if we couldn't make a call to Auth0 to authenticate our users, right? We would know that our system is not healthy. So it's really about, in my mind, it's about the connection, the interconnection of all these different moving parts, and making sure that those different moving parts are able to respond to the requests that are coming to them. Now, I know that there are other aspects of system health as well. Outside of that, a good example of that would be, if your CPU utilization is over 100% for a significant period of time, that could be a sign that your system is unhealthy. So there are other metrics that you can look at in terms of system health. But for the most part, where we have truly applied it, at least at Sudeth, is really looking at the connection, the interconnection between these systems. So if we take a look at the Estimator application, as an exercise, if we were to introduce, health check endpoints within this application, where do you think we would introduce those health check endpoints? Right, we've got a lot of connections between systems here. Quite a few, in fact. And so, the areas that I would look to introduce these health check endpoints or pretty much every connection that we've got, right? As I was talking about earlier, like if I couldn't get an auth token from Auth0, that would be a problem, right? Then users wouldn't be able to log into the application. If I can't synchronize data, that could be a problem, could be a sign of an issue. If I can't connect to the database, that would be a sign of an issue. If I couldn't generate proposals for the application, right, that would be an issue. If I couldn't write to Azure Blob Storage or the SQL database, that would be a problem. If I couldn't create an order within our transportation management system, that would be a problem, right? So what typically I like to do is to take a look at the architecture of a system, look at all of the connection points, and determine how can we layer in health checks for each of these points. And then you can think about, you know, what are we going to do in the context of the web application? Well, yeah, you guessed it. It's going to be the same thing. And then what about the admin application? Yeah, it's going to be the same thing. Right now, you don't have to implement all of these at one time. All right, typically what I like to do is I like to take the most critical path within your application, apply a health check endpoint there, monitor that health check endpoint, and then, you know, introduce, this is more of an advanced topic, but introduce some intelligent alerting into it as well, so that you know when, you know, that critical path within your application is not operating, right? Now, if I were to think about the estimator application, that area would be, there are two areas, but the one area I would really focus on is the ability to create a move. Like if we can't create moves, then we've got a problem, right? So the area that I would tackle first, ignoring everything, would be, yeah, the line between the hybrid connection and the transportation management system. That's where I would add, you know, health checks. Because if we can't create moves, we're not doing business. And we need to know that. All right, so let's talk about some of the libraries we have available to us in terms of health checks. All of these, of course, are NuGet packages. You can install them into your projects. So you've got the health checks, which is really the base library that you have available to you. The UI client is a way to get a UI that will render for you, that will tell you what the health of your system is for the health checks that you've registered in your system. And then Microsoft has implemented a collection of health checks for us, right? So some examples here is they've implemented the SQL Server health check and an Azure Blob Storage health check. And not only that, but you can write your own. In our case, we didn't have an implementation of the Auth0 health check, so I wrote one. And it's not that complicated. And I'll show you an example of a custom health check a little bit later. All right, so again, we're just adding some libraries to our CS proj. So that's always step one. And then step two is adding it to your startup or whatever class you've got, right, where you're registering these resources. Let me just open this up in another window so you can see this a little bit better. Okay, so here's an example where what we're doing is, one is we're adding the health checks. So that's always step one. And then step two, what I'm doing here is I'm adding the health check for SQL Server and for our Azure Blob connection. And so, you know, because we've added these dependencies into our project, we will then get that health check endpoint that we can call, where we can see whether or not our system is healthy or not. So with the database health check, you just have to give it a unique name. That's why we have the name and the tags there. And then all you have to do is really just provide it the connection string. And then with the Azure Blob Storage, you have to provide it, again, the connection string. Now, of course, if you're familiar with Azure, you wouldn't have these things inside of your app settings files. Typically, what we do is we use ARM templates and we express these as environment variables, where iConfiguration can read both from the environment and it can read from app settings files. So locally, you can test this by reading from an app settings file, but when you deploy this into a production context or any context, it's not your development machine, then what you would do is ensure that those environment variables are a part of your release pipeline, so that when the application runs in Azure, that it's just pulling those things out of the environment and not through an app settings file. All right, let's pop back over here. All right, so we've added these things to our startup, which is pretty straightforward. And then all we have to do is turn on the health check endpoint. So in Azure, you can see in the, I guess it's in the about fifth from the bottom or something like that. You can see that you've got a health check option here on your resource. And then all you have to do is come in and enable it. The default path for that is going to be /health. And so that exposes that API endpoint for you so that you can hit that health endpoint and then get the health of your application. You can also do this through ARM templates, and that's typically what we do because we don't like, clicking buttons inside of Azure. We'll provision all of this stuff through ARM templates, and it works just fine. All right, so now that we've gone in and we've added these libraries, we've added the I'll call it the bootstrapping of the health check endpoints or health check libraries in our startup, and then we've enabled this health check endpoint. Then what does it look like when you hit that health check endpoint? I think this is a Firefox representation. It looks a little funky, but what you can see here is you can see the status up at the top, right? It says that it's healthy, and it tells you how long it's been healthy for, and then you can see those other resources there. There's that estimator DB check that I had. It says it's healthy. There's the the Azure Blob Storage is right below it. You can see that those two containers are healthy as well. And of course, if they're not healthy, then instead of seeing healthy, you would see unhealthy, or you may see something like degraded, which is something that you would see when you hit that health check endpoint if any of your resources are not in a healthy state. Now, this is something that you can do. We don't do this at Suddeth, but you can configure your application to make webhook calls when things aren't behaving the way that they should, like when things aren't in a healthy state. But here's some sample code. I pulled it right off of the link. And I'll share this presentation at the end so that you can pull it down. It's all in GitHub. But if you clicked on this link, it'll take you to some documentation that basically shows you this right here. We don't do this because, I guess the main reason why is that you have to implement that webhook endpoint, right? And then you have to do something with it. You certainly can if you want, but if that is something that you want to take on as a responsibility, that option is available to you. So you can say, hey, when things are not in a healthy state, I want you to make this call to this endpoint. And just to give a sense of what we're doing, so we use, I believe today we use something called SmartBear. I don't know a ton about it. Our DevOps team uses it, but they use that tool as a way to probe our health check endpoints and to understand the health state of our applications. And then they have the ability to do things like restarts and things of that nature. So, and I'm sure there are a ton of tools in the market to do similar type activities. This is the UI that you get if you use the UI library for the health checks. It tells you the resource and if it's healthy or not. We don't use this at Sudeth. I'm not a super fan of dashboards and just, I feel like I'm stuck at looking at a TV or something like that all day. But if you do want to have a dashboard that's like on a television inside of your organization, it might be useful to have something like this up, right? You can have a single place where you can see the health of your entire system and see if anything is in an unhealthy state, right? You walk by the TV, you see some red, and you're like, okay, we got to go dig into this thing and figure out what's going on. We don't have a large TV that we can look at, so we don't take advantage of the UI part of the health check library, but it's there and it's available if you wish to use it. All right, so how do we incorporate the health check UI? Again, it's pretty straightforward. Not a lot of code here. If you're familiar with how to register these things within the .NET platform, a lot of this will look very, very familiar to you. But if you decide to incorporate the health check UI into your application, my recommendation would be to have it be a completely separate application. That way, it's off on its own, and you can configure all of your health checks independent of the applications. All right, let's talk about a custom health check. So we talked about this a little bit already. Here, this is what we did for Auth0, and some things have been removed for brevity. But here, all you really have to do is implement this interface, iHealthCheck, and that's all there is to it. Now, the level of complexity that's in here is completely up to you in terms of how you want to implement it. In this example, we're just verifying that that we can authorize to the Auth0 API endpoint, and if we can't authorize to the Auth0 API endpoint, then we return a degraded response back. So pretty straightforward here. And again, the level of complexity that you go to implement is completely up to you, but all you have to do is implement this iHealthCheck interface. And then, of course, you have to register it in your startup, just like we registered the SQL Server one in the Azure Blob Storage. Okay, so that was a lot of material, and that was just health checks. So now we're going to transition over to monitoring. All right, so I've talked about health checks, how to introduce health checks into an existing application. The libraries involved, the process involved. Now we're going to talk about monitoring. And the tool that's available in Azure today is Application Insights. Application Insights is pretty amazing in my opinion. I would highly recommend if you're using Azure to use Application Insights. It costs you, well, it will cost you something, right? But it's totally worth it. Let me just put it that way. The benefits that you get out of it are tremendous based on my experience with working with Application Insights. And the extensibility of Application Insights is just is incredible. So we're going to talk about Application Insights in the context of monitoring. All right, so here you can see some of the things that Application Insights monitors, right? This is page 1. There are multiple pages here, but Application Insights monitors a lot of stuff. Requests, dependencies, exceptions, traces, custom events and metrics, performance counters, and more, right? And then in the Applications Insights SDK, you have these 3 concepts, and there are more concepts inside of the SDK, but I really want to talk about these 3 because I think they're pivotal to layering in Application Insights into your applications. So the Telemetry Client is really the client for the SDK. So we'll talk about that. You have a telemetry initializer, which allows you to enrich and enrich the telemetry that you're capturing with additional data. So if there's additional data that you want to add to what you're capturing in Application Insights so that you can query against it, then the telemetry initializer is where you would do that. And then you also have this telemetry processor, which gives you the ability to discard telemetry. So, you know, anybody who's worked with logs knows that sometimes the log messages are very difficult to consume because there's so many of them, right? It's difficult to sift through them. Sometimes in a telemetry context, you can run into the same situation. There are things that you really don't care about, right? That just happen to be in your telemetry output. So the way that you can filter those things out is through the telemetry processor. And the way I look at it is it's reducing the signal to noise ratio. Like you really want to focus on the things that you really care about. And this is a knob that you can turn in order to do that. All right, so we'll talk through the Telemetry Client API real quick. There's a lot of stuff here. And, you know, a number of these things we don't use at Sudeth, but I thought that it would make more sense just to have them all here. And again, in the link inside of the presentation, it takes you right to this material. But you can have telemetry all the way to your UI. So the App Insights SDK has an SDK for JavaScript, right? And so you can incorporate it all the way into your UI all the way to your backend if that's what you want to do. We don't do that at Sudeth. It doesn't, for us, it's not a value add for what we're doing. For us, it's more interesting to handle more of the backend services, but you can take advantage of the App Insights SDK for JavaScript to get that full end-to-end picture. That's where this track page view comes into play. Track event. So with an App Insights, you can create your own custom events. App Insights itself has custom events as a part of the default implementation, but you can create your own. And this becomes extremely powerful. And we'll demonstrate that a little bit later. Get metric. Get metric is a way for you to provision a metric in App Insights, and the SDK will aggregate those metrics over time and then flush them out to App Insights. The idea there is that you have get metric and you have track metric. You don't want to call track metric because what track metric does is track metric means that you are responsible as the developer for the aggregation aspect of the metric that you're capturing. So if you're tracking things like, you know, the number of records that you updated in the database, as an example, right? You don't want to call track metric because you'll be responsible for collecting that, aggregating that, and then at some point in future, flushing that out to App Insights. If you use get metric instead, the SDK takes care of that for you. So you use get metric, and then there's a method on get metric called track. And that's really what you want to do, unless you'd like to roll your own aggregation and publication algorithm, which you might. Track exception is exactly what you think it is. It's tracking exceptions. Track request. Track trace, so any diagnostic logging that you're doing, you could use track trace to capture that. Track dependency, an example of a track dependency is making a call to a database, for example. And, you know, the SDK takes care of some of these things for you out of the box. Some of them it does not. So it's interesting to dig into the and into how it works to understand what it does for you and sometimes what it doesn't. All right, so how do we add this to an existing application? Well, all of this is in NuGet packages. You've got Application Insights, ASP.NET Core. In fact, you've got a whole bunch of different Application Insights derivatives. I'm not sure if they have a .NET Framework one or not, but if you look at NuGet and you just do a search for Application Insights, many things will arrive. But this is the main one that we're using. And also, if you wanted to, if you had a logging framework that you were using, for example, we're using Serial Log at Sudeth, and you may be using the standard iLogger, it doesn't really matter. There are ways to hook in Application Insights into your loggers, so that if you prefer to use the loggers instead of the SDK directly, you can do that. I would say the downside to that approach is that the flexibility that you get with the SDK is far greater. But if you want to just, log, traces and informational messages and things like that, you can use the loggers and then find the connection into Application Insights for the logger that you're using, and then it'll just work out of the box after you configure it. Typically, the documentation for these loggers is pretty good, so yeah, just follow their READMEs and you should be fine. All right, so here we just add them to our CS proj files, no big deal there. And then here we go, we're just going to add it to our startup. So add Application Insights Telemetry. That's it. So there's not a whole lot you need to do just to get some basic capabilities out of the box. Now, there is a trick to this. It's not really a trick, it's just a reality. You have to, in order for this to work, obviously the resource has to exist within Azure. So Application Insights is a resource in Azure, and there's a way that you connect to that resource. So what we have to do, there are multiple ways to do it. But one way to do it is, again, we use ARM templates to deploy everything, and then with every resource we release out to an environment, it has a corresponding Application Insights resource bound to it. And so when you go out to that Application Insights resource, it will have an instrumentation key and a connection string. Both of those things, of course, are whited out here because I don't want you writing telemetry to our Application Insights in dev. But what you can do if you're testing this locally, which I highly recommend, is you can just update your app settings file. And then as long as you have the connection string, or you could use the instrumentation key, but you have to do that in a special way. But here is how you would do the connection string. You just paste the connection string as your value here, and then you're up and running. You don't have to do anything else. And again, the connection string is presented on the resource up in Azure. But as long as you have this defined in your app settings, you're good to go. Okay, and then you've effectively, now you've added Application Insights monitoring to your project, and it didn't take a lot of effort. So with that minimal effort, let's see what we get in return. All right. So what I'm going to do is I'm going to show you an example. Provided this will get out of my way. Let's see, is this it? Yeah. So hopefully you can see that okay. But this is just some very simple code. This is our synchronization code for Estimator. It calls a bunch of methods, does some stuff, returns an okay response, right? But there's nothing here. Right? There's no Application Insights. There's no nothing. All right. So let's see what we get for the minimal effort that we put in to incorporate Application Insights. All right. So what we can see here is I did a synchronization call. Let me just open this up in a new window so you can see it. Oh, wrong one. Is that it? Ooh. Okay, so here you can see, here are a series of activities that happened, apparently 38, right? Doing a synchronization call. You can see that here's a timestamp of the call. You've got an operation ID here. You've got an item type, which tells you what kind of telemetry event occurred. So we've got a request, we've got dependency, and then the name of the event, whether it was successful or not. This one says false, but that's okay. And then the performance bucket here, which tells you how long it took to execute on this. We did absolutely nothing, and we were able to get this output. We didn't have to add, we didn't have to bring in Telemetry Client, we didn't have to make any calls to any APIs or anything like that. But out of the box, we can see that we're able to get some value right out of the gate. Bear with me a second. Nope. All right. So we didn't do anything. All right. So let's look at it with an exception. So I did an example, same example, and then I threw an exception. Now this is a little bit of a different view, but what you can see here is that you can see that you have a 500 error up here. It's a little hard to see. Okay. But we have a 500 error here. But the thing that I thought a little odd about this is that I couldn't see the exception. You know, I just threw a silly exception that said, hey, I threw an exception. Now in the UI, I could see that, oh, I got a 500. So at least I can see that, but I can't see any, I don't have any context about it other than I have a response code of 500 and it failed. But again, we haven't really done anything with the SDK other than just plugging it into our application. All right. Now, here's an example where I did some stuff, right? I introduced the telemetry client, and then I just logged the exception. I didn't do anything else. I put a try-catch block around that code that we just looked at, and then I just did a track exception. And then now I can see that I've got a call stack here, right? A minimal effort. Just put a try-catch block around it, track exception. Now I have exception. I have the exception stack trace right here in Application Insights. That can be super useful, right? You could write queries against this and see, you know, the errors that are occurring and where those errors, you know, what part of the system that error is occurring in, right? But very minimal effort. I immediately get a call stack here in the UI. Okay, so that's helpful. But what if I wanted to know what user was logged in when this occurred, or when things are occurring within the system? It would be helpful to have that information, right? So now we're getting to the telemetry initializer. We talked about that. And so here's some code that we wrote in order to capture the user ID, the logged in user ID for the logged in user. Not a lot of code, it's very, very minimal, right? But when we do that, one of the things that you can see is that user authenticated ID is now filled out, right? And again, this is very minimal effort that has been done in order to layer this in incrementally into this application, right? So what we've done so far is we did two things outside of just adding the libraries to our project and then bootstrapping them within our startup. Is we captured an exception, we logged it, and then we implemented that telemetry initializer to add some additional context so that we can see who the authenticated user was. So we're layering these things incrementally, piece by piece. All right, so now this is where it gets fun. All right, what if I wanted to take this to another level and capture some custom events around our application? So I'm just going to open this in a new tab so you can see it. And there's a lot of stuff here, okay? But this is the telemetry library at work, okay? So here, the first thing that I do is I do a start operation. And the idea here is with the start operation, App Insights uses something called an operation ID to correlate all these events together. And when you do a start operation, it's like saying that everything between the start operation and the stop operation are related to each other. And so everything will be correlated by that operation ID, as I understand it. But one of the things that you're going to see here is that we're creating these custom events. So if the data comes in and the model state's bad, what I do is I track an event that said we had a bad request. And then I also captured what's called metrics data. So within this track event, you have two things that you can capture. You can capture additional metadata that you can put into the second argument. And then the third argument are metrics that you want to capture. So what I'm capturing here is the fact that this process failed. Now, if we look at what's below, we're capturing more things. Now, this is the same code that I showed you before that had none of this stuff in it earlier. But here, what we're doing is we're capturing things like, all right, we're updating proposals. How many failed? How many succeeded? Of the batch of proposals that I received. All right, we're updating proposal user shares. How many failed? How many succeeded? Update mover suite requests. How many failed? How many succeeded? Now, the thing that to me that's interesting about this is that we're designing the telemetry that we want to capture about our application so we can query it at a future date and see the performance of the application over time, right? And so we start very incrementally, very simply, and then what we do is we start to layer in this additional complexity so that we're designing for how we want to be able to query our system at a future date. And I know we're running close on time here, so let me bump through. Again, additional stuff. But what I'll show here is here's the track exception. And then here's the stop operation in the finally, which closes the activity. Okay, now here's an example of what you would see. And it's not perfect, but you can see here that we had a success custom event, and this was logged in Application Insights. And you can see all of these metrics, right? How many deleted records did I have? How many deleted proposals, templates, blah, 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 right? And you can see these metrics that were captured, right? Which are all things that we can query against our system at a future date and time. All right, we'll talk about this very quickly. I know I only have 2 minutes here, but on the telemetry processor, this is a way for you to filter out the telemetry. And this is a very simple implementation. All you do is implement iTelemetry processor. And this is just the structure of the implementation. What's more interesting is what's in these methods handle telemetry. So let's look at that real quick. And this is all done very simply, but the idea here is to say, hey, when I'm dealing with trace telemetry, here are things that I don't want to see in my output, where the operation contains health and swagger. So basically what I did is I looked at my output in App Insights, and I did a query, and I saw all of this noise that was in my output. And then what I did is I came in to this processor, and I went ahead and said, here are the things that I don't want to see in my output, because they're muddying up my output. And that is the intent of this telemetry processor. So it's a good way to increase signal and reduce noise. All right, last thing, and I know we're at time here, but from an observability standpoint, there is a language that was defined by Microsoft called Kusto that gives you the ability to query your system. And Kusto is something that you could spend an entire hour going through the details of. But what I want to do is I just want to show something to you very quickly. Okay, and here is, actually, this is not Application Insights. Bear with me one moment. Here's Application Insights. All right, so if I go over to logs real quick, one of the things that's pretty cool about Kusto is that when you go into the logs, it gives you a bunch of queries that they've done out of the box. So the cool thing that you can do here is that you can just execute these and then start pulling apart the syntax of it. So let's say I wanted to look at, just real quick, let me find failed operations. Okay, so here, just by executing this, it's going to tell me, how many failed operations did we have in the last 24 hours? And it's going to show me those operations that failed and how many times they failed and how many users it impacted, right? That's super useful information to have. Let me go to another one. Let's look at another one. What about response time? Kusto can also draw graphs for you, so you can see, over time, and they have different graphs that they implement as well. So you can see over time, like your response time trends. Right here, it's 12 hours ago, but you can change this to, I don't know, 7 days ago. Right, then you can see a graph of your response times. We'll come back out and come back in. Let's do operational performance. So you can see here the request counts that have occurred. Now this is within the last 24 hours, but you can see what was the average duration, your percentiles, 50th, 95th, and 99th percentiles. And this is super useful, right? So you can start querying your system and look at the performance of your system, and then start to isolate and work on those aspects of your system to start improving these baseline metrics, right? And Kusto would be a tool that you would use to do that. And quite simply, to get started with it is that you can just use some of these out of the box things and then just start tweaking them to your own needs. We talked about the Kusto query language. We talked about that. And then the last part of this is, Azure monitoring also has alert capabilities built into it. You could do an entire presentation for an hour on the alert capabilities in Azure. I know that exists in other platforms as well. So I just left that as an exercise for the audience, because alerts are a very tricky thing to get right. And so what I have found based on our experience at Setup is we have continued to have to refine how we define these alerts over time just to get them right. But that is also something that you'll want to mature to as you continue layering in these observability, health, and monitoring into your systems. And that is what I have for today. So appreciate everybody's time. Sorry, I'm over by 4 minutes.
All right, thank you, Michael. We have a couple of minutes. 3:15 is the next time. So if anyone has any questions for Mike, we're all good here. All right, thanks, Mike. Really appreciate you being able to present over the Zoom meeting here. Appreciate it.
Thanks. Take care.